Okay, so in 4.1 we've been discussing finding relative extrema and absolute extrema. And the problems that we've been given have provided us with a picture, or at least we could make our own picture from an x squared or an x cubed graph. But I want to transition into problems if they don't give us a picture, how can we still figure out where our absolute extrema are, and then eventually where our relative extrema are? And so if you look at the first three graphs on the screen, if you've noticed that all of those absolute extrema, right? Those are all absolute minimums or maximums. All of those absolute extrema happen at those little, can I call them humps? But instead of calling them actual humps, what do you notice about the graph at all of those different points? And think about calculus. What is happening in calculus at all of these different points on our graph? Well, it looks like to me, at all of these different points on our graph, isn't the derivative or the slope zero? And so those absolute extrema occur when my derivative equals zero. It has a horizontal tangent for a second, right? If you look at the next two graphs, let's say these points were kind of plugged in and they were closed circles. I have an absolute maximum here, I have an absolute minimum here, I have an absolute maximum there, or I can even have an absolute minimum here. Those absolute maximums or minimums occur not when the derivative equals zero, but those occur actually when the derivative either does not exist, or if you've noticed, they're all at endpoints as well. And so I can have absolute extrema a couple of different places. If they took away my picture, I know that absolute extrema can occur when my derivative equals zero, when my derivative maybe doesn't exist, maybe there's a sharp curve and there's an absolute extrema there, or my absolute extrema could happen at my endpoints. So we're going to use that idea, if they don't give us a picture, to find all of those different places. Those places are actually what we call critical numbers. If f is defined at c, right, so if f has a value there, there's no open circles, we can find our critical numbers when the derivative equals zero or when the derivative does not exist. Those are what we call our critical numbers. So when we have those smooth curves, maybe a sharp curve, or a place where my derivative doesn't exist, those are my possible absolute maximums or minimums. Now, remember, relative maximums or minimums can only occur at those critical numbers where the derivative equals zero or doesn't exist. Relative extrema don't occur at endpoints, only absolute extrema do. And so I can find those critical numbers. Oh, that's what we said down here. So absolute extrema can occur at critical numbers and at endpoints. Okay? So if I took away your picture and I asked you to find all of the absolute extrema, we would have to follow a few steps. So if I want you to find the absolute extrema, if I take away your picture, the first thing we would have to do is find all of our critical numbers. All of the places where our derivative equals zero, those smooth curves, or where my derivative does not exist, maybe some of the sharp curves or something like that. What we're then going to do is take those critical numbers and we're going to plug them into my original, because I want to see where I'm at. Am I high? Am I low? And how high or low is my value? So I'm going to take all those critical numbers, I'm going to plug them into the original to see what my y value is. But who could be higher or lower than any of those relative extrema? Well, can't my endpoints be higher or lower? And so that's what I'm going to do in my third step, is I'm going to take my endpoints and I'm going to evaluate them in my original. Now that I have my critical numbers plugged into my original, I have my endpoints plugged into my original function, I can then look at the y values and figure out which one is the highest and which one is the lowest. I can find the absolute minimum and absolute maximum value, my extrema. So, number one, find my critical numbers. Remember, that's when my derivative equals zero or doesn't exist, smooth curves or maybe sharp curves. I'm going to take those values and plug them into my original because I want to see where I'm at. But then I can figure out where my endpoints are because those could be higher or lower. And so I'm going to evaluate my endpoints in my original and then compare